In this lesson, we'll introduce a very important system in the brain called the working memory system, sometimes called working storage. This system operates over a few seconds. It's a temporary storage system. It allows us to manipulate information, and it helps in focusing attention on the task at hand. So working memory stores information from other brain areas for a short time so that the information can be manipulated, like when we're doing mental math, used for long-term memory retrieval, guide attention, or sustain a goal to guide behavior. Now we're going to compare human brains to computers, and we know that in computers we have two kinds of memory systems. We have the RAM memory and the hard drive, the long-term memory system. And they have different characteristics. The RAM memory is a fast access system but a small capacity. So when we run a program on a computer, we load up information into the RAM memory so that the central processor, the CPU, has quick access to that information and can do computations quickly. But it's a limited capacity memory system. The hard drive, we have slower access to that information, but much larger capacity to store information in the hard drive. Well, so too in brains, we have two kinds of memory systems. And we're going to say that working memory system in the human brain is like the RAM of the computer. And then the long-term memory system in the human brain is like the hard drive in a computer. Now, where is the working memory system located on the brain? Well, when scientists give subjects a task that involves working memory, they detect activity in two main areas of the brain. There's a region in the frontal cortex and a region in the parietal cortex. Now, it makes sense, really, that working memory would involve these two areas of the brain because remember the distinction we made. The back part of the brain was sort of answering the question, what is happening? Whereas the front part of the brain was trying to figure out what to do. So it makes sense that the working memory system is engaged in these two regions. It's as if this part of the working memory system is collecting information about what's going on and sending it to the forward working memory part of the system so as to then make a decision as to what to do with that information. Notice also the words thought and forethought. We're going to associate that with our working memory system. Now we're going to focus though on the frontal cortex part of the working memory system just as a simplification. And so we're going to put a box in the frontal cortex here. And this will indicate our working memory system. So our experience of our own working memory includes whatever it is that we're currently perceiving or thinking about. So whatever's inside this box will be what we're consciously experiencing. Now the working memory system, of course, is influenced by your goals, and whatever goes on in the working memory system will be influencing what decisions and actions you take the next moment. But we also have that other long-term or other memory system, the long-term memory system, and we'll use these hard drives as our icon for the long-term memory system. So we have a short-term memory system, the working memory, and long-term memory system. Now we'll associate the cerebral cortex in general with the long-term memory system. So there are memories that can be stored in frontal cortex as well, but we're just going to put the icons down here in temporal cortex for now. Now, working memory then allows information to be manipulated. Let's say you were asked to add the products of 5 times 5 and 3 times 2. Notice what you have to do here. You first have to figure out the product of 5 times 5 and then keep that in mind as you figure out the product of 3 times 2, and then you have to add them together. So this engages the working memory system. We're manipulating information and keeping information ready to do some further computation. Now, we may have already stored in our long-term memory what is the product of 5 times 5. Maybe we remembered our times tables. 5 times 5 is 25. So the working memory system can be interacting with the long-term memory system to help solve this task. Now in this diagram, we're going to just try to figure out what the working memory system is doing when we're simply perceiving the world around us. So we've got our brain, we've got the box representing working memory, we have visual cortex in the back of the brain, and we've got the retina in the eyes here. So the retina will be sending visual information to the back of the brain. And then what's going to happen is the visual cortex will be sending information into the working memory system. So let's say we're outside and we're looking at a tree. So the retina sends visual information to the visual cortex, and then in the visual cortex, a certain set of neurons will be activated by the tree. So we can call them tree neurons, for example. And our little icon here, these would be little neurons, and we just have them in a loop here. But the idea is just a set of neurons will be activated by the tree stimulus. Those activated tree neurons are going to send that information up into the working memory system. And so then we will have a conscious perception of a tree. Again, the contents of working memory are sort of what we're consciously experiencing at the moment. Now, the way we've drawn this is that we've got these loops of neurons here. And the idea is that so long as we're looking at the tree, we're setting up this communication between the tree neurons and the working memory system. Loops of activity. So we have electrical signals racing up to neurons in the frontal cortex, and then they're sending signals back to the tree neurons, and we've got these loops of neural activity. So we're going to associate the working memory system with this kind of interaction, this loops of activity that create the content of the working memory system. Now let's see what would happen though if, while we're outside, we shift our gaze from the tree to the cat. Well, we're assuming we've seen cats before, so in our visual cortex we have already sort of tuned up some neurons that respond to cats, and we have memories of what cats look like, so we can identify them. So you might expect as we shift our gaze to the cat, the tree neurons are going to stop their activity. So the loops with the frontal cortex are going to stop with the tree neurons, but we're going to activate the cat neurons, and they will set up loops of neural activity with the working memory system, and then we'll have a conscious experience of seeing the cat. And so we would just draw this in this fashion. We've shifted our gaze to the cat. The cat neurons become activated. Notice the tree neurons are no longer activated, so no loops with the working memory system. The cat neurons are activated. They set up loops with the working memory system, and we're consciously perceiving a cat. Now, it is true that since we were just looking at a tree, the working memory system can store that information. So we can, because we were just looking at the tree, it's still sort of accessible in the short-term memory system of the working memory system. But right now, during perception, we are only seeing the cat, because it's only cat loops that are currently activated. Now, working memory, of course, is involved when we're perceiving things, but we can also imagine things. So when we just close our eyes and imagine what something looks like, again, it's our visual system that is turning on and sending information to the working memory system. So we can think of that as sort of internal activation. I can close my eyes and now I can imagine a cat. I'm not seeing a cat, I'm imagining a cat. So I'm internally activating cat neurons that will then send the information up to the working memory system, and I will experience an image, a mental image of a cat. Interestingly, there is individual variation in the vividness of these mental images. Some people report that they easily see the cat in their mind's eye, and others report that it's sort of dark and there's nothing there when they imagine a cat, but they know that they're imagining a cat. Likewise, with auditory cortex, you might imagine a voice of somebody you know or hearing a song in your head. And the idea there is it's auditory cortex that is providing the content for our working memory system. And you'll recall that in the brain we had language areas, so speech area up here and understanding language back here. And so if we're having a verbal thought, the idea is it's the language areas that are in communication with the working memory system. So we want to think of the working memory system as where different regions of the brain can send information for the purposes of manipulation or doing some important task. But on the other hand, whatever's in working memory can then be sent back to vast regions of the brain for further processing. So this is why we want to call this sort of a workspace. Information in the workspace can then be broadcast back to other regions to guide further processing. And in the next lesson, we'll see how the working memory system and the long-term memory system interact in useful ways.